Good afternoon. We are Major Pro, and this is our discrete structures project. I'm Sinam.
I am Lydia.
And I'm Ron.
Okay, so this is the content we are going to be taking you through today. So I'm handing over to Lydia to take over the introduction.
So the goal of our project was to create a sum of product and product of sum calculator, and with the help of Python, we are able to create a program that allows the user to enter the degree and output values of a function, and then a truth table is generated and displayed alongside sum of product and product of sum expressions. Some of the key terms that we'll be looking at are sum of products and products of sum especially. The sum of products expression is an expression that is a sum of several product terms such that it evaluates to 1. And then the product of sum expression is also a product of summed terms which evaluates to 0. Moving on to the project methodology, we started with importing certain modules that will help us to make our products function the way we wanted. So we used itertools, and then itertools was used to create the possible combinations of zeros and ones. That was to create our inputs list. And then we also used the Tincta. That was the main library that helped us to create the graphical user interface. Let us look at some functions that we made use of. First, the user input method. So with this method, we were able to allow the user to enter the degree of the function, and that was used to create an inputs list with the help of the itertools library, so that the possible combinations of zeros and ones are created. Also, we allow the user to enter the proposition names of the various propositions in the functions, and then these names are used to create another dictionary. And in this dictionary, the proposition names refers to the keys and the values refers to the input list that had been created using itertools. Also, we take output from the user, which is the output values of the function, and then these values are stored in a list. Having done that, we loop through this output list, and then the indexes of zeros and ones are stored in separate lists. Now in the sum of products function, we compare the elements in the input list, that's the value of the dictionary, at the same index as 1 in the output list. If it is 1, we keep the value proposition name, else we add a complement sign. In the products of sum function, we repeat the same process, but this time we compare the elements in the input list at index 0 with 0. Finally, in the display method, we display the sum of products of sum expressions, as well as the truth table to the user.
Okay, so for testing the functionality of the code, we decided to test it manually, where we draw out the truth table, and how we learned in class, we draw out the truth table, and with that we used to find the sum of products and products of sum using the Boolean values, ones and zeros. And we compare it with the results we got from the code, and if they are the same, we realize that our code was accurate. So, and for checking and handling errors, we used a module that helped us to create a drop-down menu with a specific range of values to choose from, and no other values are allowed as input, so it sort of restricts the user. And we also use loops and conditionals to check the criteria of the degree being less than or equal to 4, as well as making sure the Boolean values are binary, that's 1 and 0. For propositions, we didn't have any propositions. Moving
on, we have used some universal symbols or convention that we have used in the project. Here we have several variables that include the degree drop-down, output drop-down, and input proposition name, which allow the users to input symbols like 0 and 1 to represent Boolean output values following the standard binary representation. We also have a truth table display. The truth table display is using a tabular format, which is common way to represent a logical relation in a structured manner. We also have a sum of products and product of sums expression, as displayed in standard mathematical notation, adhering to convention used in algebra. Okay, this is a summary of our project. The project implements a graphical user interface using a ThinkDAO in Python. Users can input the degree of the Boolean function and its corresponding output values. We also have proposition names that can be provided by the users. The program generated a truth table and expression for both sum of products and product of sums. It utilized universal symbols and convention commonly found in logic and graphical user interface application. The user-friendly way to analyze Boolean functions and expression. So thank you.